Yeah.
All right, morning, everybody. Thanks for bearing with the power outage and all that stuff. So to start with, any questions on homework 6? Just do Friday. How many people have their neural nets mostly working, their classifiers mostly working? Cool. Progress in the auto encoder part. Going okay. Yeah, nothing has come up that has surprised you or been different from what we talked about in class?
You're doing like I was doing better than that. Like I added more layers with like the path normalization, but time my accuracy to get much better.
So it's going to depend on a lot of stuff, exactly how good you can do. Like what was your accuracy with the original network and the improved one?
Like 45, 46.
Okay. So 45 seems on the lower side, which means you probably have a difficult font. So yeah, I wouldn't expect you to go from like 45 to 90. The other thing to look at is a bigger network probably takes longer to train. So look at the loss over the epochs, and if it's still going down, you should probably train for longer. So those would be some things to consider. But yeah, if your original accuracy is pretty low, then I wouldn't expect it to jump dramatically. I'm a little surprised you didn't see any improvement. Yeah, like in general, I would expect if you add more weights, like you should be able to do a little bit better, but it does depend on what data you have to train on. So, yeah, I'm a little bit surprised, but it might have more to do with your font choice than anything else. So you might try picking a different font and see if you get different results. Other questions? Okay. So the other thing I'll talk about. The last assignment is posted, and so it's a pair project, and so there's two options. You can either pick a data set that you want and build an interactive visualization of some aspect of the data set, or you can create a visualization of an algorithm. So we're going to be using the D3 library, which we're going to start talking about today. So yeah, these are the two options. So by Friday, please tell me who you're going to work with and what data or algorithm you want to look at, so I can kind of make sure that it's doable and appropriate. And then you'll just submit a repo with a little video of it running, so we don't have to deal with any dependency issues or whatever, and can just see it in action. So that'll be due next Friday, and that'll be the last thing for this class. So yeah, and then the summer will be wrapped up. So yeah, today and Thursday we'll be talking about the D3 stuff, which you'll need for this assignment. But be thinking about a data set that you might want to look at, or an algorithm that you would want to animate or visualize, and let me know by Friday. Cool. All right, any other questions there? Yeah,
just a question on course grading. So does this mean this won't be like a final project for 15%? These times supposed to be worth 85%, or will this be worth
I'll have to look. I don't think it'll matter that much because especially because there's only 7 assignments, so it probably doesn't really make much difference. Yeah, I would. Yeah, I'll have to see how I want to break it down, but I kind of don't think it'll matter that much. All right, so today we're going to talk about visualization, interactive visualization. So I think to lead off, we'll kind of start with some of the issues that we saw on Thursday last week when we were talking about graph visualization. So what were some of the problems we ran into when we were trying to visualize graph data? The hairball problem, right? That was kind of the most it came up really fast, right? We didn't need all that big of a graph before we got a hairball, right? And yeah, you basically can't get any useful insight just because there's too much information, right? And so how might interactivity help solve that problem? Yeah. Exactly. So instead of trying to fit the whole graph in one static view forever, right, we let the user that's actually trying to do something with it control what they see, what they look at, so they can focus on what's important or adjust the view, based on their understanding of the data. And so that can really help make sense of the data in a way that just isn't possible with a single static image. So yeah, a lot of real world data sets are just too big to visualize with a static visualization. And so this means pretty often we have to look at a subset of the data at a time. And as viz designers, we might not know ahead of time what the important subset is. And so letting the user that's actually working with the data control what's visible is probably the right approach. So we're going to look at 4 different types of interactivity that we might include in these visualizations. Okay. That supports this sort of exploration of the data set. So the 4 we're going to look at are changes of view, selection, navigation, and attribute reduction. So change of view is a pretty broad category, but a few things we might want to do are changing encodings or organization. Okay. So the encoding of the data is the types of marks and channels that we're using to look at it, right? And we might get better insights from one encoding compared to another, right? So maybe we want to switch from a pie chart to a box and whisker plot or something if we're trying to understand the distribution. And so we may change the way that we are choosing to represent the data, right? We might reorganize it. So we might want to sort our data by different attributes as we're exploring the data. Okay. And so it's the same data, it might be the same encoding, but we have reordered the elements. When we change the view, in order to basically connect the old view and the new view, the user might have to reorient. They have to figure, okay, this thing that was the first thing on my list is now the 7th on my list, right? And it takes some mental energy or memory to make that connection. So we can actually aid the user by animating transitions between views. So animation is a nice, pretty thing. Makes things look appley, but also it connects the previous view to the next view without, fully like starting from scratch when you look at the image. So we will take a look at some techniques for doing that. Another thing that we might need to do in an interactive visualization is support selection. So when we are, visualizing a subset of the data, right, the user is going to need to select what they want to view. Okay. So there's a whole bunch of different ways that we might do this, and have a few high-level questions that might help you choose exactly how you want to implement selection. So the first one is like, what elements can be selected? Are there some things that are always included in the visualization, or some that are never selectable? How do we handle? Do we support multiple selections? So can we zoom in on one data point, or can we select a group of data points and visualize something about that group? Do we always have to have something selected? Can you implement indirect selection? So say, give me all of the data points corresponding to, cities with population over 100,000, or does it make sense to do that sort of indirect selection? Okay. And then how are you going to visualize the selection? Right. So do you use a highlight or coloring or some other means of conveying that some elements are selected? Right. So depending on the needs of your visualization, right, you may have different answers to these questions and come up with a different approach. Another key component of interactive visualization is navigation. So here we are sort of moving the viewer or the camera to look at different subsets of the data. And in general, the terminology here is like camera terminology. So when we talk about panning, that refers to like physically moving the camera to point it at a new part of the data. Whereas zooming would be keeping the camera in the same spot, but making part of the but changing kind of the size of the view region. Okay. When we talk about geometric zooming, that is basically analogous to what a camera actually does, right? We zoom in and we get more detail of the things that are in the region that we can see. Whereas when we talk about semantic zooming, we might actually change the encoding or add or remove details as we zoom in or out. So if we do semantic zooming, right, as the number of elements that are actually visible shrinks, right, then the the amount of pixels that we dedicate to each item, we might add more stuff, right? We might add some text that indicates more attributes than we could see if we zoomed out and we have too many elements. So again, depending on the type of your data, there are a lot of different choices you could make for how the user navigates around the data. Okay. And then the last of the category was attribute reduction. So a lot of times when we have graph data, both the nodes and the edges might have attributes associated with them, right? And we probably don't have the space to show all of them all the time, right? And so we have to be deliberate in what we choose to display and how. So this might be user controlled, so maybe they get to choose which attributes are visualized, or maybe it's part of a semantic zooming process where as we zoom in, we show more attributes, and as we zoom out, we show just a coarser summary. Okay. A common technique here we call it detail on demand, where maybe if you mouse over or click on one of the elements, you see more of the details of the element. So these are things you probably have dealt with in some sort of user interface at some point. Yeah. Another really powerful tool for interactive visualization, which is a requirement for the data set visualization option for the Homework 7, is to provide multiple views of the same data. So animation is one way to show different either encodings or attributes of the data. But it requires the user to remember from across the transition of what they saw before and what they're seeing now. And as we talked about in the beginning of the semester, your eyes are more powerful than your memory, right? And so we would like to reduce the necessity to remember a view while we're looking at something different. So if we're doing some sort of comparison, right, being able to see both things at the same time is going to be really helpful. With multiple views, we might show two different encodings of the same data. So maybe we have a node link diagram of a graph and some sort of tabular visualization of the nodes at the attributes of nodes. So we get both the structural and topological information about the data set and also the attribute data in the same visualization. Or perhaps we're looking at different subsets of the data in different views. There's a whole bunch of ways we might want to use this. But yeah, multiple views is definitely helps us approach larger data sets, especially when there's a lot of attributes. If we are showing different encodings or different attributes of the same data, we would call this faceting, right? So I might have one visualization showing information about some attributes and another visualization showing others, right? And those would be two different facets of the same data. If I have two views with of the same data points, right? It might not be immediately obvious what the connection between those two views is. Highlighting or some sort of brushing is useful to convey that what the connection is. So maybe if you have two graph views, if you mouse over a node in one side, it highlights it in the other, so you can see that you're looking at the same data. You might also do shared navigation, right? So if you zoom or pan in one view, it also zooms or pans in the other view to keep the views connected. There are generally two categories of multi-view visualizations. So juxtaposition means putting stuff next to each other. So here our views would be side by side, and then superimposition or superposition would be putting stuff on top of another thing. Okay. Can anybody think of an example of when you have seen either of these techniques?
Maybe they share the same x and use the super.
Yeah, can you think of a real world case where you've used a visualization that either does superposition or juxtaposition? I would guess that probably in the last week, at least a bunch of you have used this superposition visualization. So when you use Google Maps, there are many different attributes to the data, right? And so how does Google Maps use superposition in its visualization? Yeah, so there's different layers of data that are available to you. So you have like a background, which is either like the satellite image or the schematic map part. You have traffic data, which is superimposed on top. You have your own route data, which is superimposed on top. You have locations of interest. I guess people that paid Google to advertise to you on top, right? So there are multiple facets to the data, right? And they're all on the same, they're layered on top of each other on the same visualization. Can anybody think of a juxtaposed visualization that you can remember seeing?
Digits.
Hmm?
Digits. 0 to 9.
So what data are you? Oh. Oh, I see. Yeah, yeah. So when you use the small multiples in the homework 6, yep. Yep. So yeah, you have multiple, images next to each other. Yep. Yeah, superposition probably would not work very well there. How about like a real world data that you've looked at? I can think of one example. Yeah.
I'm just thinking like if you have an image, you might have different types of, like different wavelengths or like different types of cameras and stuff, or it's the same image when you put them next to each other.
Yeah. So yeah, there's probably a Photoshop tool to look at the like red, green, and blue channels separately of an image. Yep. Yeah, that's good one. When I go to my bank's website, I get like a timeline view of my balance over time, and then I also get like a tabular summary of I don't know, various accounts or whatever. Right, so there I get two different visualizations of my financial situation, and they're next to each other because they're I don't know exactly how you would superimpose that. So in general, right, if we have a lot of space, juxtaposition can be pretty helpful. Superposition doesn't use as many pixels, but the upper layers have to be very sparse, right? It works in Google Maps because traffic data is lines, and the base layer is 2D. But if the traffic was like a cloud or a blob, right, it would really obscure what was underneath it. Superposition also, right, you can share axes, so things being on top of each other are a little bit more obvious there. Whereas if you juxtapose, you might it's harder to tell if two data points are really in the same spot or not. So yeah, some pros and cons with both of these approaches. Yeah, so I think that's all I have for the sort of high level outline of how and why we would want to use interactive visualization. Any questions on kind of the top line principles that we would want to follow, or why we would want to do this? So the particular tool we're going to look at for doing interactive visualization in this class is a library called D3, which is not really it's not really a data visualization library directly, but it is more of a foundation for building visualizations with. So let me give you just a quick preview of what we're gonna kind of build together. And then we'll talk about what the pieces are. So the data set that I have here is a JSON file which contains a bunch of movie data. So this is a scrape from IMDb from a few years back. And in order to keep things manageable, the subset that we're looking at is movies with Kevin Bacon in them. So the visualization, so what I'm interested in understanding is who was in movies with who. Right, so I want to know a little bit of information about those movies. So yeah, that's kind of the idea. And so I have 3 facets of the visualization here. The one on the left is just who the actors are that were in the movies. And then I have 2 other views. So the top one is so that top right view, what is that? So what, yeah, what kind of visualization would we call that? This would be our node link diagram. I don't know, looking at that, can you tell what the edges represent? The edges are co-stars. So the edges in the bottom corner there, the bottom part of that, anybody know what those edges would correspond to? That one corresponds to this movie, A Few Good Men, which stars all 4 of those actors. So yeah, some of the features that we have here. So when we add and remove actors, the most recently added actor is highlighted a little bit. How do you suppose the nodes are being laid out here? So this is going to be a force directed graph layout, which you can tell because you can kind of see the springs jiggling. All right, so and that's what we got here. So we can add and remove actors. Kevin Bacon's very important. All right, and then we have another facet, which is a timeline of these movies. So we can see when the movies came out. And there's linking between them, right? So 40 Deuce, I guess, start these actors. A Few Good Men, start those ones. It's like My Dog Skip is the most recent movie in this of the ones that we have selected. And so this is what we're going to build. So D3 on its own, right, doesn't really build this. So what this is so I basically have I have a basically just an HTML list over here on the left. And then I have and 2 SVGs over here. So SVG is image format. It's similar to HTML in that it is this angle bracketed format for nested data. The difference between HTML and SVG is just the types of elements that they have. So HTML has, divs and spans and paragraphs and lists, and SVG has circles and rectangles and text elements and groups. So it's similar format, just different types of tags. Right? SVG is a really useful format for visualization because it is graphical data, but it can be manipulated with JavaScript, so it just works really well on the web. So if we look at this particular thing here, let me try to pause it. So my SVG contains group elements. So the G there is a group, and inside of that group is a circle and text element. Right, I have line elements. Right, and so this is pretty simple or understandable representation of what the picture is. Right? It's made up of circles and texts, and the group element moves stuff around, all that sort of stuff. Right. So what D3 the library does is it connects data, so typically an array of data, to elements, either HTML or SVG, and has a bunch of convenient stuff for setting attributes and animating stuff related to the data values. So basically all of the most of the visualization stuff is on me, and D3 kind of just makes it really easy for me to specify what I want to see. So that's kind of the high level idea. It does have some kind of specific tools for data visualization. So it has this force-directed graph layout stuff in there. So I give it the positions of the graph nodes and tell it which nodes are connected, and it will run the simulation for me and tell me the updated positions. So it's got stuff like that. This timeline down here, it's got stuff built in for drawing like scales and doing all of the coordinate system transformations. So I just say, hey, like this movie is in 1988, and it will place it, you know, in the right horizontal spot, stuff like that. So it has built-in tools for that sort of stuff. But the core of it really is connecting data to elements of either HTML or SVG. So we're going to take a look at that, and we'll get kind of a tour of the library. So I'm going to swap out my JavaScript file quickly. So this is what we're starting with. So this is usually my starting point, where I just kind of do the layout of sections. So here basically it's just my HTML, like what the pieces are and I've sized stuff and whatever. This is how I start. I generally add a border to stuff just so I can see it more easily. You can use the inspector view in Chrome. So this, if you click this one here and you hover over stuff, you can see what the elements are and where they're placed. You can also, if you look at the tags down here and you mouse over, it will like show you how much space they pick up. But I generally add a little bit of CSS. So that CSS there, div border 3 pixels solid black, just says draw 3 pixels around every div, right? So I can just at a glance, you know, get basic layout stuff. Cool. So that's what we're starting with. And so now we're going to kind of build up this visualization from scratch. So what are some steps that we're going to need to get through on the way to building up the kind of final product that we saw there? So yeah, how would we start? So the first thing we need is to get the data, right? So I will show you what the data looks like. So this is what the data looks like. right. Hopefully you can all get a sense for what this kind of thing looks like. So for the particular visualization stuff I want to do, what aspects of this data seem like they're going to be important? The title of the year and the actors is probably the most important thing. So the other stuff I could probably ignore. Looking at the format of this data, how's it formatted? It's looks like it's JSON, right? So yeah, basically the first thing we need to do is grab this file, parse the JSON out, right? And then we can extract the fields that we care about. Cool.
Where did you find that data?
This data, it came from someone scraped a bunch of IMDb data. I actually don't remember where I originally got this. IMDb itself does not provide this currently. It may have at some point. There's an API, I think, and I believe you have to pay for it for I don't know, some scale, or it wasn't convenient. So yeah. There is kind of an interesting thing about this particular format of data. I don't know if people have worked with JSON before. Does anybody spot anything kind of weird about this? VS Code, a little red squiggle might give you a little bit of a hint. Yeah, it's not a list. It's actually a separate JSON object on each line. So it is not the whole file is not JSON. It is a file that contains many JSON objects. So this is also kind of an annoyance that we will have to deal with. Okay. So yeah, so that's where we're going to start. We're going to start by grabbing the data. Yeah, so D3 has some, so I guess there's a couple ways you could do this. I guess I could like embed this as a string in my JavaScript file, but that seems kind of awful, right? So really, I'm going to have to have my JavaScript grab this file and give me the string contents back, right? Those of you that have worked in web stuff, right? If you want to grab the contents of a file in JavaScript, how would you do that? If you're writing JavaScript for a web page.
You can map it. You can map the two pages.
So once I have the text, I'm going to convert each one to JSON. But how do I actually get the like string contents of the file, you know, as a string variable in JavaScript? I do like a read file, or I'll use the open system call or something like that. So if I'm running in the browser, right, I can't really do that because you know there is no file system I can access. All right, so really I'm gonna have to make an AJAX request to get the file and then get the data back. If I'm using AJAX, I have the callback API. It's a big mess. So one of the things D3 provides is some useful helper functions for accessing data. Okay. So the first one we're gonna use is the D3 text method, and this makes an AJAX request for this file on the server, and then will give me the text back. So this is what I've got so far. Oh yeah, a couple things. So this thing here is using the new JavaScript module system. So in the old days, if you broke up your JavaScript code into multiple files, you put a script tag for each one in your HTML, and then the order in which they were included was sort of like the hashtag include in C++, kind of the order that they appear is the order that you can access stuff. Modules are a little bit, they're closer to, you know, Java modules where code is a little bit more self-contained. So that's what we're using here. in order to use a module, when I include this script, I have to instead of saying the script is type text JavaScript, I say the type is module, and that's how that works. Run this. And so the code that I have so far is just calls D3 text to get this JSON file and then logs the result. And if we look over, oops, sorry. If we look at the console here, what I get back is actually not the text of my file. It's this thing promise. Have you seen this before? What's a promise? So JavaScript is a single-threaded environment for the most part, right? And if we think about what's happening when I get the text, I have to make a request to the server, get the response back, right? It travels potentially across the whole internet. And then I have to get the text, right? If I block the one JavaScript thread the whole time that's happening, then any other no other JavaScript code can run, which would include things like button callbacks or any other UI stuff, right? So I don't want to block the I don't want to block the JavaScript. That I'm going to grab a drink of water before I.
Yeah, I got it now. I got him up there. Tomorrow?
Okay. So making an AJAX request and waiting for the response takes a lot of time. We don't want to lock up all of the JavaScript stuff while it's happening. And so basically none of the things in JavaScript that take a long time are synchronous and just block until they're finished. And so a promise is a way of doing asynchronous programming where the text function returns right away, but it doesn't give me the contents. It gives me back a promise, which is an object that kind of tracks the background work that I'm doing and tells me when it has finished. And when it has finished, I can get the results. So there's two different ways that you might deal with a promise. The first is by saying, hey, promise, when you get the data, here's what I would like for you to do with it. So that's kind of a callback based API. So there's a method promise.then. So it says like, hey, when you get all of your data, pass the data to this function, So pass the text that you get to this function and I'll process it. The other, so callbacks are a pretty old technique in JavaScript. And as you write more and more complicated code, you sort of nest callbacks and callbacks and callbacks and callbacks. They're not great for dealing with errors. It's really hard to follow because it's not like straight line code. So the newer way that people deal with these sorts of asynchronous things is through async await. And so what we're going to do with this promise is we're going to await the promise, which says, hey, go do something else for a while. Stop this function that I'm running, do whatever else you need to do. So if there's button callbacks or scrolling or whatever else you want to do that. And then when my promise is ready, continue running my code from here. And then we'll keep going. So what this is going to look like is I put the await keyword here, and this says, hey, wait for this to complete, and then continue going on from here. The error message here is that you can't call await in a normal function, because this means the await says I have to pause and resume the function. And so I have to mark this function as async, which says this is a special kind of function that can be paused and resumed. So you'll see a bunch more code like this in 6018 this fall. But yeah, so that's what goes on there. And now if I run that code, look at the console, we actually get the text here. So now we have our text. So D3 text is going to do an AJAX request for us, and then has the nice promise API, so we can just stick await, and we don't have to worry about doing callbacks. So now that we've got that, we can start processing it. I'm just using I'm going to split the line, split the text on new lines, because I looked at it and I saw that we have one JSON object for each line. And so just to show that this works, I'll grab, I'll parse the line in the JSON object, and then I'll grab the title. And so let's see what that looks like. So now we see that we're getting the titles of the movies. Cool. Looks like I had a syntax error, unexpected end to JSON input. So looks like at least maybe I'm not handling the end properly. So let me just wrap this in a try catch. And now if there's an exception, I just ignore it. Cool. Yeah, so now we got our movies. And now it's time to start thinking about how we want to represent our data. I guess before we get to the data, one more detail about how I'm running this. So I'm loading the data with an AJAX request, which means that the browser wants to talk to a web server, which means that this has to be running from a web server. So I can't just like load the file from disk and then have this work. And if you look at the URL bar up here, it says I'm talking to localhost 8000. So I'm using a pretty convenient Python thing, which is that Python has a module called HTTP server, which is, oh, sorry. Python has a module HTTP server, which is a library that you can use to build web servers. But if you, it has like a main program in it. So if you run this module, it basically just serves the files in the folder you specify. And so here I'm just saying, hey, run a web server, and if anybody, when someone connects, just serve the files from this directory if they exist. So that's how all my stuff, how this is all working. This is a really convenient developer tool. From my experience over the last few years, it's basically impossible to do anything with JavaScript without running it as a server, like trying to load stuff from the file system without a server running. There's a bunch of added security features that basically make it impossible to do anything all that interesting. So if you're doing JavaScript development for web stuff, you basically have to do this now. All right, so this is what we're working with here. And yeah, you can see these are the requests I'm making. So you can see that I have a request to my JSON file here, which is again being made by d3.text is making a web request, making an HTTP request for the file, and then I'm sending it back. Okay. Oh yeah, so we've got our data, we have parsed it a little bit. So how do we want to represent this data? What data types do we want to work with in JavaScript to build the visualization that we want? So is the format that this is in a convenient format? Maybe let's think about some of the parts of the visualization, right? Like, how are we going to get this into a more useful format?
Going to change to data, right?
So we're dealing with JavaScript, so out of luck there. So right now, how is the data sort of organized? How is it grouped? Or what is each one of these objects correspond to? A movie, right? But that's not really how we presented the data in our visualization, right? So how did we yeah, how is our visualization organized? It was organized around actors, right? So we want to, basically reorganize our data around actors, right? So maybe let's ignore the movie stuff for now, right? And we're just going to do actor stuff, right? What is a good data representation for the actors in this data? What type of collection might I want to use for the actors? So a map would be like key value pair. So what would the keys and values be? And the value could be what? Sorry. The movies that they're in. Yeah, so I could I could map actors to movies, right? That would be yep, that, and then I could work with the keys. Any other thoughts? So an array of actors that works even simpler. Generally, starting with an array is a good spot. So maybe let's start with an array and see where we get, and see if we have to do something more complicated. So I'll start with an empty array. All right, I've got a JSON object for the movie. So this is a string, right? And I think we saw that it was a comma space separated thing. So I'm just going to do split on that. Let me just make sure that that worked. Yeah, so that gives me a an array of all the actors in the movie. So we're good. Okay. And so now I'm gonna add all these actors to the array of my, overall collection of actors. Cool. Except what's gonna go wrong there? There's gonna be a lot of duplicates, right? Kevin Bacon is gonna be in there 100 times, right? So array might be a good choice, except that we know we are expecting a bunch of duplicates. So what might be a better a set? So let's do that. That works. Oops. And that didn't quite work. There's probably a way to do this in one shot. Let's use a loop. And there we go. So we get a set with 137 actors. And they're assuming there's no typos in any of these, there won't be any duplicates. Cool. All right, so now we've got this is enough. This is actually enough data to do one part of the visualization. All right, so what part of the visualization can we do now? Yeah, so the little list of actors inside, right? We actually have enough to do that. So let's go ahead and build that piece. So so now we get to start using some D3. I'm going to make one. I'm just going to move. Oops. Make actors a global variable here. And so now we're going to basically populate the left panel. Okay. And so the way that this works, the way that D3 works is, again, it's about attaching data to elements of the DOM. Right? So for this particular case, right, our data is going to be the actors in our set. Okay. And then what DOM elements would we want those to be connected to? So, for each actor, what kind of DOM element am I going to have? Yeah, so some sort of text element. I think here I'm just going to use paragraph. Yeah. So to just my. So the way that this works is I select D3 is it's got like a selector kind of thing, sort of like CSS selectors. So I'm going to select the container element of where I want the elements that with my data go to. So in this case, it was the actor div. So this is my container. And then this is kind of a weird syntax. But then I select the type of element that each thing in my data should be. So in this case, I'm saying select all of the paragraph elements, which is pretty weird because if we look at my data set, here's my actor div. How many paragraph elements are there? There's none. So select all seems kind of weird. But this is kind of just the D3 API. Okay. So the next thing I'm going to do is specify, okay, so these are the elements that I'm talking about. I'm talking about all of the paragraph elements, which are in the actor div, which is currently none. But I'm just saying, hey, the data that they should be associated with is the actor data. And then finally, I use this join method, which says associate each actor with a paragraph element. Okay. So this is the type of elements in the container for each data entry. This is the data. And this says, so. Yeah. So let's take a look at this. So if I run this. So now if we look at my visualization, there's still no actors in there. But if we look at the elements and we look at what is in the actor div, there is now 137 paragraph elements. So there is a paragraph element corresponding to each data member. Okay. So we have sort of gotten what we wanted, except not, we're not done yet. Okay. So we have a paragraph for each one. So what's missing? The actual data, right? So now we're going to actually add the data. Okay. And so in D3, this thing here, the type of this thing is a selection, which is like a set of elements with the associated data. Okay. So with a selection, I can do all sorts of stuff. But what I'm going to do here is I'm going to set the attributes. So you can set the attributes a bunch of different ways. In this case, the attribute that I'm interested in is the text attribute. So what is actually in the paragraph element. So I can just pass a string here. And so this is going to say for every element in the selection, set the text of that paragraph to be hello world. And if I run this, I broke something. Nope. All right, so I got the syntax a little bit wrong. I guess text is actually a special thing. So here we go. So now I have attached the hello world. I've set the text of my paragraph to be hello world. What I had to change in my my code. Instead of the text being an attribute, there's actually a text method to set the contents. So So this is actually not particularly useful here, right? Because I want the text to be different and I want the text to depend on the data. So instead of passing a literal, I can also pass a function. Okay. Most of the D3 stuff takes a function of 2 parameters. And so D is the data and I is the index. Okay. So I know what the contents of the data is. And I also so I can also use the position if I want. Okay. So I'm just going to use the data here, which is since my data is a set of actors, each entry is going to be the string name of an actor. So I just set my text to be the data. And then voila, we have our data visualization. So this is kind of the basic idea behind D3 is I attach data to elements. In this case, I attached actors to paragraph elements. Okay. And then D3 has ways for setting attributes, properties, whatever, of those elements, and it keeps track of what data is connected to it. Okay. So that's basically the core of D3 is this connection between data and elements.
Why does it need a function? Is that why can't it just take just the set of data? Is it because you don't have it at that point?
So there's a couple of reasons. So for this case, you could sort of do that. A really cool thing about D3 is that it allows you to dynamically add stuff to and remove stuff from the set. And so it keeps track of the connection, like which element is connected to which data automatically. And so by taking a function there, it will pass the right value for you. So yeah, in this case, you could sort of, this is a case where it would be easy to do it manually yourself. But we'll see on Thursday where we're adding and removing stuff to the data, how useful it is to let D3 manage that for us. Okay. So yeah, that's kind of the core thing here is we are grouping the data with the HTML elements. Question so far? Okay. So again, the code for this is quite short. We're just saying what container is are our elements going to be in, what kind of elements are associated with the data, what data are we dealing with, and then we say, hey, like actually set it up, and then we attach the here we're setting the text attribute, and again we're using the index. Cool. Let's see. Just to show you so I can use the index here. So probably screwing up the JavaScript syntax. Yes. So here I have updated the function so that it uses the index and makes every other one uppercase, right? Probably not how you would actually use that in practice, but just to show you how it works. All right. Okay. So yeah, what's next towards building building out our visualization? We've got the list of actors, cool. Where can we go from here?
Create some sort of like action, clicking on it, and the highlights.
Yeah, so we wanted to be able to select which actors are being visualized in the graph view. And so that seems like a good next step. I actually have some support for that already. So, kind of the way that highlights how it's suggested to do highlighting type stuff in D3 is instead of setting like the color attribute of elements is to use classes. So the class specifies what the style of the thing is, and then and then you can add and remove the class. Right? There's a few reasons for that. One, whether a class is attached or not is like a binary thing. So whether my element is currently has a selected class or not, it's very easy to check. Whereas there are multiple reasons why I might change the background color to blue, for example. Right. So this is yeah, so this is the recommendation. So basically what we're going to do is we're going to, when we click on something, we're going to add the selected class. So let's start with that. So this is pretty easy. The selection element has a selection type in D3 has an on method, which takes the event. And then it takes a function with 2 parameters. For now, let's just log them. So I think you can guess what the D is. Any guesses what the E is? I don't think it's actually the event. That would be a good guess. It's another E thing. Let's see what happens when we run it. Oh, actually, no, you're totally right. That's actually not at all what I was expecting. Yeah, sorry, you're right. It's the event. It has the target. So the target is the element that was selected. But yes, it is the event. Yes, and then there's also a hidden parameter. Let me add. So the third element is the this parameter, which is the element itself. So the E is the event, D is the data, and then this is set to be the element. So the D3 select function can work with like CSS selectors. So the hash actor div there uses the ID of the element, but it can also work with elements themselves. So this basically wraps the DOM element in D3 stuff, which lets us use all the nice D3 methods. So this is the thing that was clicked. And then we can add or remove classes with the classed method. So this one, we're gonna set the selected element. And then we're going to just set it to be the opposite of whatever it was. So we're gonna, this version is reading the value and this version is writing the value. And so this should add and remove the class as we click on it. So here we go. Okay. And so, yeah, very simply, we have selection. So in terms of the questions we were asking about selection earlier, do we support multiple selection? Pretty obviously, yes. Right? Do we support empty selection? Pretty obviously, yes. Can we do indirect selection, at least as I have? I showed you kind of the prototype. Right, so we don't currently have some way of saying, give me all the actors that were in a movie with Kevin Bacon before 1990, or give me all the actors that were in A Few Good Men. Right? We don't have anything like that yet. So we could potentially consider adding it, but it's not something we have now. Right. Okay. Let's see. And then I guess the last thing we'll add here is so I could simply, I guess if I need to know which actors are selected, there's a couple of different ways I could do that. I could keep track of them with the set, right? Just have a JavaScript variable, or I can select all of the elements which are which have this class. All right, so maybe let's just add a little bit of code for that. So if I want to just print out all of the elements which are selected, you can use the select for that. And we look at what we get there. Not all that useful for. Oh, here's our array. So we have Kevin Bacon, and somewhere down here should be. So not the most convenient format, but this selection does contain all of the elements which have this class. All right, so I think we will stop there for today. So tomorrow, no class Pioneer Day. On Thursday, we will kind of continue building this up. So the things we're going to look at are the force-directed graph layout stuff. So how that's built into D3. And then we'll also look at the timeline. So that is using basically the 3D, the D3 axes, which again, just kind of deal with. They're not absolutely necessary to build this stuff. It's just convenient to say, hey, I want to work in these units, and then it handles, drawing stuff at the appropriate size for you. If you have some time, think about, what we're going to need to add to build those features. Keep working on homework 6. Start thinking about who you want to work with and what data you might want to look at for homework 7. Please let me know by Friday what you have chosen. And otherwise, I'll see you all on Thursday.